number 7?
Yeah.
Or, okay. Have we done it at all?
No, your page just.
We have to run what?
Or 2.
Okay.
Grow.
So we have
Everyone.
After high,
Okay.
there's more than was infinity.
Wait, why is this frozen? Okay, there we
Yeah, I
go.
know, I saw you.
All right. So we have so we already have the function written. All right. So it says to determine the approximate rate at which a substance decays. We did that. We got 0.89. With your equation, find y12 and y18. So let's plug it in.
Do we know? Oh, there's more colors. So do we just have an assignment then today after this? Determine the approximate rate.
Okay. So I got y12 to be 300.41 grams and y18 to be 150.31 grams. So how far apart are 12 and 18?
Barely.
6, and these are years. Okay, so they're 6 years apart, and I know it was yesterday, but when we read this, it said up here that this substance, whatever it happens to be, has a half-life of 6 years. So if you look at what we got, I got 300.41 grams for year 12, and then 150 grams for year 18. Those are 6 years apart. Do those two data values make sense? That's what they're asking. Do these values make sense?
Yes.
Yeah, because 6 years later, it's about half of what it was. Now, without even using your calculator, approximately, what would year 24? About how many grams would you expect it to be?
75.
Around 75, because it's going to be half again, because it's a 6-year half-life. Okay, so then it asks, what interval of time will the amount of the substance be greater than 400 grams? Solve graphically or by the table. So we're going to solve this one graphically. I'm going to go to my y, since I already put it in my calculator. I'm going to go to my y equals, and I'm going to put 400 grams in my y2. Now, even before I hit my button on my calculator, I know that this stuff is not going to show up in my calculator set the way it is. If it's a standard window, because look at how big these numbers are. My standard window only goes to 10 on the y-axis. So I need to reset my window. So I'm going to hit window. My x values are going from 0 to 6 on the table, and then we talked about your 12, your 18, your 24. So I'm going to go 0 to 25, and because of that, I just counted by 2. You can still count by 1, it doesn't really matter what you count by. Then on my y values, can you have negative mass?
No.
No, so there's no reason to go to the negative numbers. That's why I went ahead and put my y minimum on 0. But my y max, this is decay. The highest number in my y column is 1200, and then it goes down from there. So I'm going to change my y max to 1200. And I'm going to count by 100 just because I'm going to scale by hundreds just because that's a really big number. So now when I hit graph, it should at least show up in the window. All right, so there's my decay function. It draws it first. And there's the line that represents 400. So remember, in this case, according to this table, we put it in x, but the x-axis represents years. So over here it starts at 0, and it counts forward. And then the y column represents the mass in grams. So the question asks me, for what interval of time will the amount of the substance be greater than 400 grams? So all of this on my, all of this stuff is greater than 400 grams. All of that. So up to that intersection right there is greater than 400. So I need to know what that intersection is. So I'm going to do second and trace and intersect. It's on the first curve, which is the exponential. So I go, okay, yeah, that's good. It's on the right one. And then it jumps to the second curve, which is actually a line. And I'm good with that too. So I hit enter and enter again. So that's at 9.5 years. So after 9.5 years, it drops below 400 grams. But everything until that point is above 400 grams. So I'm going to write that as from 0 to 9.5 is when it's above 400 grams. Is everybody good? All right. So now, flip to the next page. And go ahead and you try problem number 8. I'll give you a few minutes. It's very, very similar. Hold on a second, I'll show you how I have it.
Oh, I didn't put it.
Gonna assume we don't put decimals.
You don't have to. I mean, you can just approximate all of these just because of the way it is. I put decimal on mine, but you don't have to.
Well, I don't want decimal.
And it does say it's not. It's just number of rabbits. So yeah, you're right. We wouldn't want a proportion of a rabbit. That would not be good.
Can't we just grab them all?
Yeah, you can round. Alright. So if you rounded and didn't use decimals, that's fine. And so you would get like approximately 12 times. So after 5 years, it's approximately 12 times greater. And then from 5 to 10, it's about 12 greater also. So then on this one, that when they asked for the interval of time that the number of rabbits would exceed 30,000, I had to adjust my window again, really by a lot, because 30,000. So I went into y equals and I had my original function in, and then I put 30,000 in y2. And so if I want to see where that line is drawn, I have to put at least 30,000 in my window. So I put 50,000 just so I could see it. And so it looks like that. Since this is a growth function, once it hits that intersection, everything past that is going to be greater than 30,000. So I just had to calculate I did an intersect and found that intersection. It's at about 12.8. If you use the table, you said about 13 years, that's fine. So in this case, once you hit that 13 years, you're just going to have more and more and more and more rabbits. Now we know in real life that eventually the exponential growth of the rabbits will stop because they'll either start starving to death or they'll start killing each other. But at least for a certain, but because we didn't get any more additional information, I'm just going to put x is greater than 12.8 and assume it's 13 to infinity. It's not really that, just for the purposes of All right, so I'm going to give you a few minutes to try the next one.
When I put in the calculator, it's like 2
Which thing is?
to the next problem.
On which? On what though? Where are you looking?
On graph.
On the graph?
Well, it does say 2, but you can just-
Well, minus 2, right?
It says 2e negative
I
10.
plugged exactly what it says in
That's not okay.
I mean, what are you looking at?
second, or the table.
Oh, the table, okay. Oh, that's just scientific notation. It means times 10 to the, whatever.
How are you supposed to write it in?
You can write it in scientific notation. But your table shouldn't have that.
That's what it says.
For
Should
what?
it?
Let me put it in my.
Are you talking about the problem number 9?
Yeah.
Okay, hold on. I'm going to put it in real quick and make sure.
I don't have sign
I don't need it.
Oh, well.
So basically, if there's a fault on you, you just, that's your starting factor, put some y or stuff, you just add it to your a.
How do I just get out of those practices? How do I log this screen back?
No. I just go off. And then give up. I do way more than you do at practice.
Don't, right? What do you
Don't
do?
do anything, man.
I play scout team, bro.
I'm on the scout team offense and defense. You're on scout team defense.
No.
Not on offense.
The other day when you decided to play your spot. When you were sick?
When I had 104 degree fever,
Yeah, that's being soft.
104?
Yes,
Yeah.
being soft.
It's pretty strong.
Just like Coach Hewitt. Don't even think about being
That's
sick.
why Hudson went home today. He was just over there.
Oh, shut up.
All right.
And he went to vote.
Did you get this for your table?
I thought
Not
that
rounded.
0 was always supposed to be like what it.
That's it. So I was about to ask you. So what is wrong with this? What's different than what?
It's plus 75 at the end.
Yeah, it's got plus 75 at the end. So normally our A value is this, right? Is what we find right here. But this is a transformation. This entire thing has been shifted up 75. 55 plus 75 is 130. So it is still 55. It's just all been shifted up. Every single value has been shifted up. So then it asks for us to find the ratio between y1 and y0. So I'm going to put y1 in, divide that by 0, and I got 0.873. That's my ratio. Now, when we did that before, we would get the same ratio for the whole table. But when it asks you to do it for 7 and 6, I got 0.976.
It's because there's a transformation.
It is,
Is it because it?
but why? What is that? Let's look at it. If we go look at it in our calculator, I think sometimes it helps. So let's see.
Oh, JD, some $3 the other day, boy.
You did?
Oh, good, boy.
Yo, Moms and Late came one day.
Yeah, so
All right. So this is what the graph looks like.
you can't answer day probably.
So what's happening on my graph?
What day was it?
It's leveling out.
Saturday?
At what?
75.
What is 75 in this problem situation?
Yeah, Late.
It is an asymptote. In this problem situation, though, what is it? What's happening in this scenario?
Is it like where it just originally started, like we started off with 75?
So, but what are we talking about on this problem? Did y'all actually read the problem?
No.
Coffee.
We're talking about coffee. And I set coffee on the table, and it's cooling down. So the asymptote that we're reaching is
75.
70. What is that?
Room temperature.
Room temperature.
But what if that's not your room?
And well, that's the room temperature in this problem. And the closer and closer and closer we get to room temperature, the smaller and smaller and smaller that ratio has to get, because 75 is the limit. The coffee can't get any cooler than 75 because that's room temperature. It's actually not even going to make it to 75. It'll get real close. You can go to your table, and you can go to some pretty extreme numbers, and it'll get real close to 75, but it's always got these decimals. It says 75, but look, if you highlight it, it's not really 75. It's just going to get as close as it can. And that's because we moved our asymptote up. Your asymptote on an exponential, whether it's growth or decay, is usually at the axis. It's usually at 0. But because of that shift up to 75, it affects our ratio because the asymptote's higher up. All right. Is everybody sort of kind of okay? A little bit? Okay. So we have an assignment to do. It is super easy. The first